Hello everyone. Today I am going to discuss about the pair of linear equations in two variables, where first I will talk about the basics, following which I will be discussing about the methods to solve pair of linear equations in two variables, and then I will be discussing about the word problems which will be based on these concepts. So let's just start with the basics first. So as we all know that the standard form of linear equation in two variable is of the form ax plus by plus c equals to 0. Now in this case we are going to discuss about two equations. So here if you'll talk about the first, that an equation of the form of ax plus by plus c equals to 0 is known as linear equation in two variables. Next, when we talk about a pair of equations, or we can say also that simultaneous system of equations here, so we'll be talking about two equations which will be a1x plus b1y plus c1 equals to 0, where a1 square plus b1 square should not be equals to 0. That means at any point of time a1 and a2 both should not be equals to 0. And the other equation is a2x plus b2y plus c2 equals to 0, where a2 square plus b2 square should not be equals to 0. So this is the system of pair of linear equations, or we can say system of simultaneous pair of linear equation. Now the pair of linear equation which has no solution. A pair of linear equation which has no solution is called inconsistent pair of linear equations. And a pair of linear equation in two variable having at least one solution is known as consistent pair of linear equations. So that means if a pair of linear equation is having at least one solution, we'll say it is consistent, otherwise it is inconsistent. Now when we talk about the pair of linear equation which are equivalent, in that case such a pair is called the dependent pair of linear equations. So if you have to find out a dependent equation of a given equation, just you multiply that equation by any non-zero real number, you will get the dependent equation of it. For example, if we'll take 2x plus 3y plus 10 equals to 0, and we have to find the dependent equation of it, then what we have to do is just multiply it by any real number and the obtained equation will be dependent equation. For example, if here we'll multiply it by 2, then we'll get the equation as 4x plus 6y plus 20 equals to 0, and that equation will be the dependent equation of 2x plus 3y plus 10 equals to 0. That means there exist infinitely many dependent equations for a given equation. Next, let's talk about the behavior of pair of system of equations. So when we draw the pair of equations, as we know, geometrically ax plus by plus c equals to 0 represent straight line. So in that case, when we draw the graph of a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0, it will give pair of a straight line. Now when we draw these pair of a straight line in a plane, then there will be three situations which will arise here. The first situation will be the pair of equations will be intersecting, or the pair of equations will be parallel, or the pair of equations will be coincident. That means either they will intersect, and when they will intersect at a point, or they will be parallel, that means they will never intersect. And the third case where they will be coincident, where one line will be exactly over the other line. Let's discuss about these three cases individually, and we'll also see that how we can find out what type of pair of equations we'll have without even drawing the graph of it. So first we'll talk about when the pair of equations are intersecting. So when we talk about the pair of equations are intersecting, in this case we have a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0. Now when we draw the pair of equations, in this case what will happen? The pair of equations will intersect at a point, and in this case the point of intersection will give here also the solution of it. So as we know, we are discussing about the pair of linear equations. Now again, to recall, we have studied earlier in ninth that a linear equation in two variable has infinitely many solutions. But when we talk about a pair of equations, then as the three situations arise, we'll get three different conditions, and based on that we'll decide what type of solution we'll get. So here in this case, if I want to know that what type of pair of equations it is, that means whether it is intersecting, parallel or coincident, what we are going to do, we'll check here a1 upon a2, and if it is not equals to b1 upon b2, then we say the lines are intersecting. That means we can say lines are intersecting. If the lines are intersecting, it will intersect at a point, so we can say it has unique solution. And since it has unique solution, we can also say it is consistent. As we have discussed earlier, that a pair of equations is said to be consistent if it has at least one solution. So remember, this is what we can understand when the two lines are intersecting. So these conditions are very useful, which we'll be using later on while solving the questions. Next, when we talk about the pair of equations when they are drawn and they are parallel. So how we'll identify whether the lines are parallel or not. So again, we'll take a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0. In this case, what we are going to do is we are going to find again a1 upon a2. If it is equals to b1 upon b2, we'll be checking the ratio of c1 and c2 also. And if that is not equal, then we can say that lines are parallel. And now, since lines are parallel, we know that they will never intersect each other, which means we can say that it has no solution. And since it has no solution, we can say it is inconsistent. And when we draw this system of equation, they will represent a pair of parallel lines. So this is the condition for parallel line, and again which we'll be using to solve the questions. Next is when the pair of lines are coincident. So in that case, a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0. In order to understand whether it is coincident or not, we'll have to check the ratio of a1 by a2, b1 by b2 and c1 by c2. So in this case, we'll take if a1 upon a2 equals to b1 upon b2 equals to c1 upon c2, then we can say that lines are coincident. Since lines are coincident, we can also have infinitely many common points, and so it will have infinitely many solutions. And since it has infinitely many solutions, we can say it is consistent. And in this case, one more special thing we'll observe that the pair of equations are dependent. Let's summarize all the three conditions together. So let's start with the questions. So in this case, the first question is, find out whether the pair of linear equations are parallel, coincident or intersect at a point. The equations are 5x minus 4y plus 8 equals to 0 and 7x plus 6y minus 9 equals to 0. So as we have discussed, what we are going to do here is, we'll take 5x minus 4y plus 8 equals to 0, and 7x plus 6y minus 9 will be equals to 0. Now if we will take the value of a1, which will be 5, b1 that is minus 4, and c1 is 8, a2 is 7, b2 is 6, and c2 is minus 9. Now if you find out the ratio of a1 by a2, which is 5 upon 7, and b1 upon b2, that is minus 4 upon 6, which is minus 2 upon 3. And as in this case we see that since a1 upon a2 is not equals to b1 upon b2, therefore pair of equations are intersecting. Next question is, find out whether the pair of linear equations are consistent or inconsistent. Again, to check whether it is consistent or inconsistent, we are going to find again the ratio of a1 and a2, b1 and b2, and c1 and c2, and based on that we'll answer our question. So if you talk about the first question here, we have 5x minus 3y equals to 11 minus 10x plus 6y equals to minus 22. Now one thing we need to remember that when you decide a1, b1, c1 and a2, b2 and c2, the equations has to be written in the standard form. So if you write the equations in the standard form, we'll get 5x minus 3y minus 11 equals to 0, and minus 10x plus 6y plus 22 equals to 0. Now the value of a1 is 5, b1 is minus 3, c1 is minus 11, a2 is minus 10, b2 is 6, c2 is 22. Let's find out the ratio. a1 upon a2, that will be 5 upon minus 10, that is minus half. b1 upon b2, that will be minus 3 upon 6, which is again minus half. And c1 upon c2, which is minus 11 upon 22, which is again minus half. Now in this case, as we see that the pair of equations satisfy the condition of coincident line, so we can say since a1 upon a2 equals to b1 upon b2 equals to c1 upon c2, therefore lines are coincident, and therefore we can say that pair of equation are consistent. So this is how we can solve the first question. Moving towards the second part of it, where we have the pair of equations 3 by 2x plus 5 by 3y equals to 7 and 9x minus 10y equals to 14. Let's write down it in the standard form. We'll get 3 by 2x plus 5 by 3y minus 7 equals to 0, and 9x minus 10y minus 14 equals to 0. In this case, the value of a1 is 3 by 2, b1 is 5 by 3, c1 is minus 7. And if you'll take a2, that is 9, b2 is minus 10, and c2 is minus 14. Let's find out the ratios now. a1 upon a2, that will be equals to 3 upon 2 divided by 9, which will be 1 upon 6. b1 upon b2, that will be 5 upon 3 divided by minus 10, which will be minus 1 by 6. And here we can see, since a1 upon a2 is not equals to b1 upon b2, therefore lines are intersecting, and hence it is consistent. Moving to the next question. Here we have, check whether the pair of equations 2x plus y equals to 6 and 4x minus 2y equals to 4 are consistent or inconsistent. So again we'll apply the same logic. In this case, we have 2x plus y minus 6 if you write in the standard form, and 4x minus 2y minus 4 equals to 0. Here a1 is 2, b1 is 1, c1 is minus 6, a2 is 4, b2 is minus 2, and c2 is minus 4. Let's find out the ratio. a1 upon a2 will be 2 upon 4, which is 1 upon 2. b1 upon b2 will be negative 1 by 2. And as in this case, we see that since a1 by a2 is not equals to b1 by b2, therefore the pair of equations are consistent. So we can say pair of equations are consistent. Moving to the next question. The next question is, find out whether the pair of linear equations are consistent or inconsistent, and if consistent, obtain the solution graphically. Pair of equations are 2x plus y minus 6 equal to 0 and 4x minus 2y minus 4 equals to 0. So in this case, if you will take the first line, which is 2x plus y minus 6 equals to 0, and 4x minus 2y minus 4 equals to 0, where a1 is 2, b1 is 1, c1 is minus 6, a2 is 4, b2 is minus 2, and c2 is minus 4. If you will take the ratio of a1 upon a2, which is 2 upon 4, it is 1 by 2, and b1 upon b2, that will be negative 1 by 2, since a1 by a2 is not equals to b1 by b2, so the pair of equations are consistent. Now, in order to find the solution of it graphically, we'll have to draw these two lines on the graph sheet, and for that we'll have to plot the points. As we know, to draw a line, we need minimum 2 points. So let's rewrite the first equation. We can write it as y equals to 6 minus 2x. So here, if you take x equals to 0, the value of y will be 6, and if you take x equal to 1, the value of y will be equals to 4. Similar way, if you find the second equation, it will be 2y equals to 4x minus 4, which can be written as y equals to 2x minus 2. Now in this case, if you will take x equals to 0, y will be minus 2, and if you will take x equals to 1, the value of y will be 0. Now on plotting these points on the graph sheet and drawing the line, we will get this graph, and based on this, if you will check, these two lines are intersecting each other at point 2, 2. Therefore, we can say that 2, 2 is the solution of these pair of equations. That means x equal to 2 and y equal to 2 will satisfy both these equations, and it will be the solution of these pair of equations. Moving to the next question. The question is, given the linear equation 2x plus 3y minus 8 equals to 0, write another linear equation in two variables such that the geometrical representation of the pair so formed is first intersecting lines, second parallel lines, and third coincident lines. So if you will talk about the first one, the equation is 2x plus 3y minus 8 equals to 0. So when you want to write a line which will be intersecting to this line, ensure that the ratio a1 by a2 should not be equals to b1 by b2. So in that case, we can easily guess that what can be the equation. Here if I will write it as that 4x plus, now it has to be the other multiple, as you know, 2 and 4. 2 will divide 4 2 times, we'll take 3 into 2 is 6. Other than 6, we can take any other value. So here we can write it as 7y minus 11 equals to 0, and that will fulfill our requirement. If you will talk about the parallel lines, so what we can say in that case, what has to be that A1 upon A2 has to be equal to B1 upon B2, not equals to C1 upon C2. That means A1 by A2 should be proportional to B1 upon B2. That means if my equation is 2x plus 3y minus 8 equals to 0, I can multiply the first two values, that is coefficient of x and y, with a fixed number. So in that case, we can write it as suppose 4x plus 6y, and then we can take in place of 8, ensure that it is not the same multiple. So let's multiply with some other value, that will be minus 24 equals to 0. So as in this case, we can check here 2 by 4 is equals to 3 by 6, which is both half, but it is not equals to minus 8 upon minus 24, which is 1 by 3. So it will satisfy, and that's the solution of it. We can make many such examples. Now the third one is coincident line. So remember, coincident line can be obtained by just multiplying the given line with any non-zero numbers. So here, if we have 2x plus 3y minus 8 equals to 0, you can choose any specific number and you can multiply it. I am going to multiply it by 2. So this will be 4x plus 6y minus 16 equals to 0, and that will be the pair of equations, and it will satisfy our requirement. As if you check, 2 upon 4 will be equals to 3 upon 6, which will be equals to minus 8 upon minus 16, all are equals to half, and so the lines will be coincident. Remember, sometimes they can ask you that write the dependent equation, that is also the same thing. Moving to the next question, we have draw the graph of the equation x minus y plus 1 equals to 0 and 3x plus 2y minus 12 equals to 0. Determine the coordinates of the vertices of the triangle found by these lines and the x-axis, and set the triangular region. So in this case, we are going to again plot the points in order to draw the graph, and then we'll see how the triangle will form, and then we'll mention about the vertices. So let's take the first equation. So if you'll take the first equation, we'll get x minus y plus 1 equals to 0, which I can write it as y equals to x plus 1. Now, if you will take x equal to 0, y will be equals to 1, and if you will take x equal to 1, y will be equals to 2. Let's take the second equation also, which is 3x plus 2y minus 12 equals to 0, which we can write it as 3x equals to 12 minus 2y, and so x will be equals to 12 minus 2y upon 3. Now taking the value of x and y suitably, we'll put y equals to 0, we'll get x equals to 4, and if we will take y equals to 3, then x will be equals to 2. And now we'll plot these points. We will get this particular graph, and here this equation represent y equals to x plus 1, and this represent 3x plus 2y minus 12 equals to 0. Now in this case, we see that the region bounded by these two lines and x-axis is the shaded region, and in this case the lines intersect here, x-axis at minus 1 comma 0, at 4 comma 0, and this is 2 comma 3. Therefore the vertices are, if we write this one as A, B and C, so A will be minus 1 comma 0, B will be equals to 2 comma 3, and C will be equals to 4 comma 0. So this is what the vertices of triangle will be. Moving to the next question. The next question is, find CE if the following system of equations have infinitely many solutions. So in this case, if you'll observe, the value of A1 is equals to C, B1 is equals to 3, C1 is equals to 3 minus C. The value of A2 is 12, B2 is C, and C2 is minus C. Since pair of equations have many solutions, therefore we can say A1 upon A2 will be equals to B1 upon B2, which will be equals to C1 upon C2. On substituting the values, we'll get C upon 12, which will be equals to 3 upon C, which will be equals to 3 minus C upon minus C. Now solving 2 at a time, we'll get C upon 12 equals to 3 upon C, which means C square is 36, and so the value of C will be plus minus root 36, which is plus minus 6. Next, if you take the next two pair, we'll get also 3 upon C, which is equals to 3 minus C upon minus C. On doing the cross multiplication, we'll get 3C minus C square, which will be equals to minus 3C. Bringing all the terms to one side, we'll get C square minus 6C equals to 0, which means C is common, C minus 6 equals to 0, which implies C will be equals to 0, or C minus 6 will be equals to 0, which will give C equals to 6. Now, also we can take the first and last, that is C upon 12 equals to 3 minus C upon minus C, and when we cross multiply, we will get minus C square equals to 36 minus 12C, which will give C square minus 12C plus 36 equals to 0, which on factorization will give C minus 6 whole square equals to 0, which means C will be equals to 6. We can observe that C is a common value between all the three, so therefore we can say the value of C is equals to 6. Moving to the next question, we have find the value of K for which the pair of equations Kx equals to y plus 2 and 6x equals to 2y plus 3 has infinitely many solutions. Again, in this case, since pair of equations have many solutions, therefore A1 upon A2 will be equals to B1 upon B2 will be equals to C1 upon C2. So what we'll get on writing the equations in the standard form, we'll get Kx minus y plus 2 equals to 0 and 6x minus 2y minus 3 equals to 0, where A1 will be equals to K, B1 is minus 1, C1 is 2, A2 is 6, B2 is minus 2, C2 is minus 3. So what we can write, therefore A1 upon A2 equals to B1, which is minus 1 upon B2, that is minus 2, equals to C1, which is 2, and C2 is minus 3. Now here if you observe these two, then what we find is 1 by 2 is not equals to minus 2 by 3. Therefore, there is no such value of K for which the pair of equations have many solutions. So there is no such value of K exist. This is all for this session. In the next session, we'll be continuing with how to solve the pair of linear equations, where we'll be discussing about the methods to solve, that is substitution method and elimination method, and then following which we'll be discussing about the word problems. Thank you. Take care everyone.